when we think of average rate of change as something different than just slope, where we're seeing how fast the values change in a function over time, we can look at different types of functions instead of just straight linear lines like we've got from this do now, and find their average rate of change. And it's really going to be the same kind of method as we use for finding the slope, but we get to use it in lots of different contexts. So here's one to start out with. Let's take a look over here. First, let's start by just graphing that guy. So I'm going to go to my y equals, and then I'll put in x squared plus x minus 2. Our graph should look something like that. And let's just go to the table to help us actually plot those points. So I'm going to hit second, go to the table, and I've got these different points here that I'll start plotting. Let's try. So I've got negative 3, 4. Negative 3, 4 is one of them. That's that guy right there. Next I've got negative 2, 0. Negative 1, negative 2. 0, negative 2. 1, 0. We're all the way down to this one over here. And then 2, 4. And I'll end there because that's when it stops going off. So here's my graph. It should look something like that. So it's going to have a little dip between those 2 points there. So I'll try my best just to draw it like that. Kind of like right there. So now normally you can't really find the slope of this whole thing because it's going down here and it stops and it starts going up. But if we're just thinking about average rate of change, I just want to see how fast my function is moving from any given set of points. So what we're going to do is just, let's look at this point B right here. We're going to plot the points 2, 4, so that's this guy right over here. And then the point 0, negative 2, that's this guy right over here. And we're going to draw a line there. So even though we can't find a slope for the whole thing, we can find the slope between these 2 points by just drawing a straight line between them. So let's find that slope there. I'm going to just use, well, I'm going to use the formula. I'm going to say, all right, well, I want my change in y. So I'll start with this one first. 4 minus negative 2. Those are my y's. And that gets me 4 minus negative 2 is going to be 4 plus 2. It's equal to 6. That was change in y. And now I'll do my change in x, which is this guy over here, this 2, and the 0. Since I started with 4 at the front, I have to start with 4's friend over here, 2. So I'll start with 2 minus 0. That's the change in x. It's going from 2 to 0. 2 minus 0 is 2. That was my change in x. So the slope between these 2 points is going to be 6 over 2. And if we simplify that, 6 divided by 2 is 3. The slope of the segment is 3. Now, the average rate of change on the interval from x equals 0 to x equals 2, well, here was x equals 0. That was this point right over here. Here I've got x equals 2. That's this point right over here. And my average rate of change is just going to be the slope, the average rate of change just for these 2 points. So that's just going to be 3. So we get to see how, even though it's sort of a different idea and you say, well, I can't find the slope of this curve thing here, if you ask, well, what's the average rate of change between 2 points in this function, you're able to see it just by finding the slope there. And that's it. It's as easy as that.